Hello guys,
It's Tebo Pengu. Today on my first video, I would like to teach you on how to do integration by parts. So consider we need to integrate x squared e to the power of 3x with respect to x. Okay, so you first thing you need to know is to how to choose your u and how to choose your dv from the equation, and then you substitute. So we have this equation, a standard form equation, which is the integral of a u dv equal to uv minus the integral of a v and du. So here we need to substitute the value the u, we need to find the v, we need to find the du. So we start by looking at the u and dv. So how do we find a u and how do we find the u and dv? Okay, so how do we choose and how do we see that maybe x squared must be u or dv, or e to the power of 3x must be u or dv? So there is something that is called a laity. It's laity. There is e. So the L stands for log, and I stands for the inverse, and A stands for the algebra, and C stands for the trigonometry, trig function, and E stands for exponent. So now you ask yourself, is there a log here? If you can notice, there is no log. Is there an inverse? If you notice, there is no inverse. Is there an algebra? Yes, there is an algebra. So that one is your x squared, which is the algebra, and it will be your u, and therefore the rest that is remaining will be your dv, which is e to the power of 3x and dx. So from here we need to find a du and a v. So we can see by looking at this one, if we can integrate here, we can find a v, and then therefore here we need to do a derivative of x squared, and therefore we will find a du, and then we make the du as a subject of the formula. So if we can do that, we have a du over dx. So we need du equal to the derivative of x squared is 2x, and then we make du as a subject of the formula, and therefore we will have a du, then we times both on the left hand side and the right hand side by dx, and therefore we will have something like this, which is 2x and dx. On this side we need to integrate both sides. So we will have the integral of dv equal to the integral sign of e to the power of 3x and dx. So when we integrate 1 with respect to v, and therefore our answer will be v equal to, and the integral of e to the power of 3x will be e to the power of 3x over 3. The 3 is just a constant here, so it's a coefficient of x, so it will be here. Okay, now we need to go back and substitute on our formula, which is the integral of u dv equal to uv minus the integral and the v and du. So our u, we said our u is x squared, and we said our v dv is e to the power of 3x dx equal to, and we have our u, which is x squared, our v, which is e to the power of 3x. So if we multiply x squared and e to the power of 3x over 3, it will be something like this. So minus the integral of v, which is e to the power of 3x over 3, and our du is 2x and dx. All right, so now we need to simplify here, and we can observe by looking at this, we can see that there is a 2 over 3, which is a constant. So whenever you have a constant, you just take it out, and then you are left with everything that has or attached with x, so that you integrate with respect to x. So we need to take out the constant, which will be a 2 over 3. So we will have the integral of x squared and e to the power of 3x dx equal to x squared e to the power of 3x over 3 minus, then we take this 2 over 3 as a constant, so 2 over 3, and integral of x and e to the power of 3x and dx. So if we notice again, we actually seeing the product times the product. So we need to again find the u and find the dv. So of course there is an algebra and there is an exponent. So the algebra comes first from Liati, if I may write it again. So it's a Liati. You ask yourself, I said you ask yourself, is there a log here? No, there is no log. Is there an inverse? No, there is no inverse. Is there an a, which is an algebra? Yes, there is an algebra here. If we can see, it is x, and that one will be your u, and our u is equal to x, and of course our dv is equal to e to the power of 3x and dx. Okay, most people, they forgot to put dx and say dv is equal to e to the power of 3x. So don't make that mistake, because you need to integrate with respect to x. Okay, so here we need to now derive x, and we know that the derivative of x is 1. So we say du over dx is equal to 1, and we make du the subject of the formula, and therefore we will have a du equal to dx. And then we integrate on this side. We have a dv, integral of dv, and integral of e to the power of 3x and dx. So basically it is the integral of 1 dv. So the integral of 1 or any constant, it will give us the constant times the v, which we are integrating with respect to. So in this case, our constant is 1, so 1 times v, it will be v equal to, so if we integrate again, so it will be 1 and the same thing, which is e to the power of 3x over 3. Okay, all right, and then we substitute on our formula. So we have the formula, which is look like this: integral of u and dv is equal to uv minus the integral of v and du. So we know our u, which is x. We know our dv, which is e to the power of 3x and dx. So if you can see here, it is same as this one is what we are looking for, or what we supposed to be integrating, but now we integrate by parts twice. So equal to our u is x, our v is e to the power of 3x. Again, we multiply everything, it will be 3, and we have a minus, and integral of v is our v is e to the power of 3x over 3, and our du is dx. Okay, now we have 1 over 3 here, which is the constant, so we cannot integrate if we have something like this. So we need to take out the constant and then we integrate. So we have the integral of x and e to the power of 3x dx equal to x e to the power of 3x over 3 minus 1 over 3. We take out the constant and integral of e to the power of 3x and dx, and then lastly now we need to integrate this part, and then we go back and substitute everything here. Okay, so integral of x e to the power of 3x dx is equal to x e to the power of 3x over 3 minus 1 over 3, and I put a bracket, so it will be e to the power of 3x over 3, and we do the multiplication here. So we will have the integral of x e to the power of 3x and dx equal to x e to the power of 3x over 3 minus 1 times e to the power of 3x. It will remain the same, so it will be e to the power of 3x, and 3 times 3 which is 9. And now we have integrated this part, which is the integral of x and e to the power of 3x and dx, and is equal to everything here. So now we need to just substitute. So if I may do it here, so we have the integral, which is everything here, so it will be the x squared e to the power of 3x and dx, and equal to the x squared e to the power of 3x over 3 minus 2 over 3, and we substitute everything here. Okay, I will be having a problem with the space, so but we can continue and have and substitute e to the power of 3x over 3 and minus e to the power of 3x over 9, and close the bracket, and plus our c, which is the constant. So we have the integral of x squared e to the power of 3x and dx is equal to, so bring down this, so we'll have x squared e to the power of 3x over 3 minus 2 times x e to the power of 3x over 3, so it will be 2x e to the power of 3x, and all over 3 times 3 it will be 9 and then a negative and a negative, it will be our positive, and therefore 2 times e to the power of 3x which will be 2, and e to the power of 3x over 3 times 9, which will be our 27, and plus our constant. And this is the final answer for our first problem.